So the question is asking you to find what volume of this initial solution is needed to prepare this new solution that has a less concentration and only has 75 milliliters. Well, in dilution, our moles don't change. So let's go back to our initial equation where molarity is equal to moles over liter. Let's reorganize this. Let's make this moles is equal to molarity times liters. Well, what we just did was decrease the molarity and then have some sort of change for our liters. But we only added water to dilute. Dilution is only adding water. We're not adding any more moles. So our moles stays the same. So moles is constant, right? So what we could do is have our mole equation right here is equal to two different solution concentrations. So if we have a molarity initial and a volume initial, and we have a molarity final and a volume final, both those solutions will have the same amount of moles. They just have different concentrations and different volumes. So that's exactly what we're about to do. We're going to calculate how to find this little volume initial. So we know our molarity initial is 1.5 times our volume initial, which we don't know. And our molarity final, our new concentration, is 0.25 times our new volume, which is 75 milliliters. But let's keep it in liters and make it 0.075 liters, right? So our volume initial, Li, is just going to be this divided by 1.5, which will give us 0.0125 liters. Now we want this in milliliters because this is really ugly. So let's make that milliliter. So we'll multiply by 1,000 milliliters per 1 liter, and that gives us 12.5 milliliters. Now we also know we only have two significant figures right here. So let's make this two significant figures, and that gives us 13 milliliters.